So we're going to expand today. We were doing the rational expressions where we multiplied and divided. And then in the last class, we added and subtracted rational expressions. I'm going to change the title to my note sheet here just a little bit and just call it rationals, because we now are not going to be doing just expressions, but today we'll be doing equations. Okay. So again, what we did before, and I'm going back a couple of dates here. So we had these rational expressions where we were multiplying them. So you factor the top and factor the bottom, and you look to cancel whatever you can. And our answer was an expression. It had X's in it typically. Okay, so we did, we did a couple of those. Like our answer looked like that in that case. Then in our last class, we were doing adding and subtracting rational expressions. So, this would be a good example where we factored the bottom and we got our common denominator of x plus 2, x minus 2. And then we had to, so like in this case, we had to multiply top and bottom by x minus 2. Here we didn't have to change anything, so we just left that as 3. But here I had to distribute the 7. And then we combined our like terms. And again, our answer was an expression. All right, so today is going to be a little bit different, that we are going to be now solving equations. So here we go. We are solving rational equations. And I'm trying to kind of make a big deal of the difference between equations and expressions, even though it's pretty easy to figure out, which is which. An equation obviously has an equal sign. But the reason it's so important to recognize that early is because the method in solving them is much different. So like here would be a rational equation. All right, let's say we had 2 minus 3x over x plus 1. And that equals negative 5 over x plus 1. So first things first, notice this is an equation because of the equal sign. And because of that, it's a different method than we did before. We're not going to start factoring and canceling here. For a rational equation, we do want to figure out the common denominator, which in this case is x plus 1. And what we're going to do is multiply everything by the common denominator. So I'm actually going to write that in parentheses up here. We're going to multiply everything by the LCD, okay, by the common denominator. So in this case, the common denominator is x plus 1. So I'm going to do this. I'm going to write x plus 1 here. And notice what I'm not doing the top and the bottom, just the top, which we can do because it's an equation. If it were an expression, we can't do just the top. All right, so now the reason we multiply by the common denominator is so that we can cancel the denominators out. And so our next line, I'm going to distribute that to, would be 2x plus 2 and then minus 3x, because the x plus 1's canceled, equals negative 5. All right, so that's the huge step. It gets pretty easy from here on out in terms of solving that, but multiplying everything by the common denominator. And when you do that, all the denominators should cancel out so that in your next line, you do not have any more fractions. So if you still have fractions, you're doing it wrong. We should not have any fractions in that next line. And now it's just, combined like terms type of thing. So we get negative x, and I'll move the 2 over. So negative x is negative 7. And x comes out to be 7. All right, so let's try another one here. So our next example, we'll have x minus 3x plus 2 over x plus 1. And that equals 1 over x plus 1. So again, we're going to multiply everything by the common denominator. So the common denominator in this case is x plus 1 again. So I'm going to write x plus 1 here, x plus 1 here, and x plus 1 here. And I would really suggest you write that out. It doesn't take long to do. Some of you are going to say, I don't want to write it out every time. I'll just remember to cancel it. Don't do that, at least not until you get really good at these. It's just way too easy to make a mistake. So we multiply everything by the common denominator and then cancel all the denominators. So x plus 1's cancel there and there. And so now I'm left with x squared plus x, because remember I have to distribute that, minus 3x minus 2. Don't forget, that negative goes to both of those terms also. So far we have x squared plus x minus 3x minus 2 is equal to, looks like we just have 1 on the other side. So again, my second line should not have any fractions. It doesn't, so I'm feeling pretty good about how this is going. This is a quadratic. We got to get everything on one side, and hopefully we can factor that or use the quadratic formula. So when I combine like terms, I get x squared minus 2x minus 3 is equal to 0. So I moved everything to the left. And with any luck, this will factor, which it does, into x minus 3 times x plus 1. So that skill of factoring is huge again. And so we get x equals 3 or negative 1. All right, one last thing we have to do is, remember, rationals mean fractions. And in fractions, we can't divide by 0. So we have to check for extraneous solutions. An extraneous solution is anything that would make the denominator equal to 0. So for example, negative 1 is an extraneous solution. I have to throw that out, because if I plug negative 1 in for x, it would make that 0, and you can't have a 0 in the denominator. So when you're checking for extraneous solutions, just go back to the original problem and make sure that anything that makes the bottom equal to 0 is not one of your answers. 3, of course, is okay, you know, because 3 doesn't make the bottom equal to 0. So thinking about extraneous solutions in the previous one, as long as x was not -1, I was okay. So 7 is fine to plug into the denominator there. So don't forget to check for extraneous solutions. All right, any questions yet? We doing okay? All right, because the next one's going to get a little harder here. Not too bad. All right, let's say we have 1 plus 2x over x plus 2 is equal to 8 over x squared plus 2x. Now, this one is different because I don't have the same denominators. Like before, you know, my denominator was x plus 1 for both of them, so my LCD was fairly easy to find. In this case, it's not too bad. I still can find it, but I need to factor all the denominators. So that factors into x times x plus 2. And so that means my common denominator is x times x plus 2. So I'm going to multiply everything by that. X times x plus 2 there, x times x plus 2 there, and x times x plus 2 there. And our reason for doing that is because we want to try and cancel all the denominators.
Wait, Mr. O'Connor, what are we specifically looking for to like as our common denominator? Because like I probably would have done x plus 2 or just, yeah, I probably would have just done x plus 2.
I'm sorry, I'm having trouble hearing you.
How do you know like that's the common? Like how do you cancel x plus 2 from the second, like from 2x over x plus 2? How do you cancel that out if you're doing x plus 2?
So what you do is you only cancel what's in the denominator. So in the second part, you know, your question, that x plus 2 cancels with that x plus 2, which means I'm going to get 2x squared up top. That x still stays there, and I have to multiply it by the 2x. So
okay.
Okay. Now for the other part though, both the x and the x plus 2 cancels. So I'm just going to have 8 on the top there. So in our next line then, you know, nothing canceled over here. So I have x squared plus 2x. Okay, I just distributed that. Here I have 2x squared, so plus 2x squared. And that's going to equal 8.
Wait, Mr. O'Connor?
Yeah.
What about the x? It didn't cancel. Like, you know how there was like x and then parentheses x plus 2?
Yeah, could you say that one more time? X time. Yeah.
Yeah.
This x?
The x, yeah, it didn't cancel, right?
Correct. It did not cancel. So I multiplied that x by 2x to get 2x squared.
Oh, okay.
Okay. So like this part became that. This part became that. And 8, of course, is 8. Okay, so you guys are getting it. You're right that x does not cancel, and that's different than the previous problems. All right, we again have a quadratic now here. So we got to get everything on one side. So I've got 3x squared plus 2x minus 8 is equal to 0. And now we can try and factor that or use the quadratic formula. So I would try and factor it for about 20 seconds. So let's see if that was 4 and 2. And if I had plus 2 and minus 4, looks like that's going to work. It factors into 3x minus 4 times x plus 2. Now, if you have trouble factoring that because the leading coefficient is greater than 1, do the quadratic formula if you're good at that. So don't forget our two answers are x equals 4/3. That's what's going to make this equal to 0. And -2. However, hopefully some of you at home are saying, wait a second, we have an extraneous solution, because we do. So -2 is extraneous because that, of course, would make x plus 2 equal to 0. So we have to throw that out. So our answer is just 4/3.
Wait, could you repeat that?
Yeah. So we have, we got our answers of 4/3 and -2. But -2 is extraneous because that would make the denominator equal to 0. So anything that makes the denominator equal to 0, we have to throw out. We can't keep that as a solution. It's extraneous.
So basically the way we like check if the answers are right, we just like plug them into the denominators before we cancel them out.
Yeah, you plug them into the denominator, and just to make
Okay.
sure it doesn't give you 0.
Okay. And the common denominator that we use to cancel, or just all of them?
Really,
Like,
all of them, but the common denominator, remember, encompasses all of them. So it's easiest just to plug it into the common denominator.
Okay. Okay.
So like in the previous one, since we had -1 as one of our answers, that would make that denominator equal to 0. We had to throw that out. That was extraneous.
Okay. Are they common, like in the problems that we're gonna do?
You know, they are fairly common. Yes. I mean, I think common enough to where you're definitely going to want to check.
Okay.
Yeah.
Thank you.
Yep. Good questions, but they should be quick checks too. You know, I mean, you can, well, let me write the next problem. So I have -6 over x minus 8 over x plus 8 is equal to -5x over x plus 8. So in terms of our extraneous solutions, I can already tell if I get -8 as an answer, I have to throw it out. If I get 0 as an answer, I have to throw it out. So it shouldn't be too hard to do that. The hard thing is just remembering that you have to check for that. So our common denominator is x times x plus 8. So I'm going to multiply everything by x times x plus 8. And our reason for that is so that we can cancel all the denominators. So working left to right, the x's cancel out. And in the middle, the x plus 8 cancels out. And on the right side, the x plus 8 cancels out. So what we're left with is, don't forget that -6 we're going to distribute. So that's going to give us -6x minus 48. Okay, -6 times 8 is minus 48. And then in the middle, I have -8x. And on the right side, I have -5x squared. Okay, so this part came to here. Our -8x came from there. Our -5x squared came from there. And I do not have any denominators. I mean, of course, there's one, but so I feel like I have canceled all those out, so I'm probably doing this correctly. Now we want to get everything on one side. I'm going to move everything to the left just so I have a positive leading coefficient. So we would get 5x squared minus 14x minus 48 is equal to 0. And now we want to try and factor this guy if we can. So let's see. I'll try 5x and x. And 8 times 6 would be 48. So that would be, that's not going to work like that, is it? So 8, 6 is not going to work there. Say that again. 12 and 4. 12 and 4 is going to give us 20 and 12, right? Yeah, so I don't think we're going to get 14 from that. Let's try and reverse.
24 and 10.
Try 4 and 12.
No, 24 and 10.
24, well, 24 and 2. Gotcha.
Wait,
Yeah, I got your 10. Yep.
Yeah.
So we got our 10x and our 24x. So that's looking very promising. And so if we had positive 10x and negative 24x. So our solutions are, x is going to be, in this case, that's going to be 24 over 5. And in this case, -2. And neither of those are extraneous, so we're in good shape. You know, and again, because only 0 or -8 would be extraneous. Now, one thing that some of you may or may not know, when we got to here, 5x squared minus 14x minus 48 is equal to 0. We can use our calculator to solve that. If I went to new and calculate, under the toolbar, and whoops, under algebra, I could hit solve and type it in. 5x squared minus 14x minus 48 equals 0. I have to tell the calculator what to solve it for. So I hit comma x. And look at that. It will give us the answers that we got. We got 24 over 5 or -2. So your calculator on your iPad will do the quadratic formula or factor for you essentially and be able to solve those very quickly. So that's a nice feature that you, if you get used to it, you know, you could use to get these answers. Because I'm just saying that because it took us a little bit of time to come up with this, although we were able to do it. we're all at kind of different levels in terms of our factoring ability.
Mr. O'Connor, what if it doesn't work? Like, let's say that 48 was a 47. What would
Yep.
what would it look like?
It would look
Um,
ugly. So if I did this, I think what you're saying is, so if I wanted to solve 5x squared minus 14x minus 47 equals 0, and I wanted to solve that for x, look at those ugly answers. That's what you would get if you use the quadratic formula, and it would not factor.
Okay, cool. Because I'm guessing you're looking for it not to be those answers at all.
Correct.
Okay.
Yep. Yeah, no, it's a great question. You're exactly right. All right, any other questions before I have you guys try some on your own? All right, well, so let's check out this class kick and see how we did. Feel free to jump in with any questions. So for the first one, I'm going to start off first. I know that if I get -1 as an answer, that is extraneous. Okay, so I have to make sure that I don't get -1, or if I do, I throw it out. I'm going to look for my common denominator, which is x plus 1, and multiply everything on top by x plus 1. So once we do that, in the middle, the x plus 1 cancels. On the right side, the x plus 1 cancels. And so what we're left with is 2x plus 2. Okay, so that turned into that. Minus 3x. That came down here. Is equal to -5. That -5 came down here. So all of our denominators are canceled out. So I will get everything together. I got -x equals -7. And so x comes out to be 7. All right, next one. So looking at this, if I get -7 as an answer, I'll have to throw that out. I know that x plus 7 is my common denominator. So I'll write x plus 7 here, x plus 7 there, and x plus 7 there. So in the middle, x plus 7 cancels out. On the right side, x plus 7 cancels out. So when I multiply that out, I get x squared plus 7x. So this became this. We have minus x in the middle. And that equals 7. So now it's a quadratic. So x squared plus 6x minus 7 is equal to 0. We'll try and factor that. So I think it factors into x plus 7 times x minus 1, meaning our answers are -7 and +1. Don't forget to check for extraneous solutions. Don't do all that great work because -7 is extraneous, because that would make the denominator equal to 0. So we only have one answer, x equals 1. All right, so last one. I'll factor this into x times x plus 6. And so my common denominator is x times x plus 6. So I multiply the first parts by x times x plus 6. The middle parts, x times x plus 6. And the last part, x times x plus 6. X plus 6's cancel on the left side. Both the x and the x plus 6's cancel on the right side. So in our second line, I have 6x squared. That came from here, 6x times x. Now for the middle part, don't forget that negative sign distributes to both of those. So that's minus x squared minus 6x. Okay, negative x times x plus 6 is minus x squared times minus 6x. And that equals 8. Now it's quadratic. So I'll get everything on the left side here. I get 5x squared minus 6x minus 8 is equal to 0. Try and factor that thing. 5x and x. 4 and 2 would give us 10x and 4x. So as long as I have negative 10x and positive 4x. So it factors into 5x plus 4 times x minus 2. And so our answers are x equals negative 4/5 or 2. Both of those answers are acceptable. The only thing that wouldn't be would be 0 or negative 6. And so we're done. We get 2 solutions for that one.